Welcome back to Statistical Reasoning. Today we are going to start Chapter 3, Describing, Exploring, and Comparing Data. The first section that we're going to talk about deals with measures of center. There are four that we work with: the median, the mean, the mode, and the midrange. The mean is the first one that we'll discuss. The idea of measures of center are we're finding information that helps us know about the center or the middle of the data. The mean is the one that we most commonly know in everyday life. It's where you add up all the numbers and divide by how many there are. You may have also heard it used as the term average. In statistics, we don't use the word average because average describes all of the measures of center, and therefore we wouldn't know which one we wanted to talk about. Things that you need to make sure you know about the mean: it is the one that varies less than any of the others when it comes to regards to the population. It is definitely used in everyday life and everyday values. Some of the disadvantages, though, of the mean is that it is what's called not resistant. If a term is resistant, then when you have extreme values or values that are different than everybody else, then it won't be affected by it. But since the mean uses every single number, it must be affected by it, and therefore is not resistant. These are some of the notations or symbols that you need to make sure you know. The first one is a capital E in the Greek language, and it's sigma, and it means sum. So it just tells us to add up all the numbers. X is what we're going to use to represent each individual data value. N is how many numbers are in the sample, and N is how much data is in the population. So here we have how to find the mean. Notice this is an X bar. This is the symbol that's used for the sample. It tells us to add up all the values and divide by how many there are. We already knew that. Mu is the term that is used when we talk about the population. So this symbol versus this symbol, we do the same thing. We add them all up, but this time we're dividing by how many are in the population versus how many are in the sample. So here's our first example. We have some air data speeds. They are measured from smartphones from 4 different carriers. We're going to find the mean of the first 5 data sets. So based on our formula, which said to sum our x's and divide by n. So we're going to add up the 38.5, 55.6, 22.4, 44.1, and 23.1. So you do that while I do that. So when I added those all up, I got 153.7. We have 1, 2, 3, 4, 5 numbers, so we'll divide by 5. I get 30.74, and that is my X bar because that is the mean for those 5 samples groups, or 5 sample numbers. So another one, and we've already talked about this part. I was ready to move on to median. So median is the middle number when you put them in order, and that's the important part, is they have to be arranged in order. The median is resistant to extreme values because it doesn't use all the numbers, it just uses the ones in the middle. So those extreme values, which tend to be on the edges, are not affecting the median. The notation for the median, I'm going to use the capital M here. You will sometimes see MED, and very rarely have I ever seen the X tilde. So to do this, we're going to sort them. I'm going to always do from lowest to highest, and then we're going to find the one in the middle. If it's a single value in the middle because it's an odd amount of values, then it's easy, it's just the 1. If there's an even amount of values, you have to do a little bit more work and you have to find the mean of those answers, of those 2 numbers. So here we have the first 5 data sets that we've already worked with. Our job is to first put them in order. So we're going to put the 14.1 first because it's the smallest, 22.4, 23.1, 38.5, and 55.6. So now I find the one in the middle, and I just underline them so I can still read them, but I'm crossing out one on each end until I get to the center, and so my median is 23.1. Now here I have 6 data values, so I put them in order, and then I still have to find the one in the middle. So here they are in order. If I go through and find the one in the middle, I see that I have 2 of them, so I have to add them up and divide by 2. So if I have 6, in this case, it's 23.8. Notice that my answers are labeled. Make sure you're doing that. So the mode is the one that occurs the most often. The mode can be found with not only quantitative data, but with categorical data. Sometimes you will not even have a mode, or you can have more than one mode. If you have 2 modes, it's called bimodal. If you have more than 2, it's called multimodal. So in this example here, 1, 2, 3, 4, 5, 6, 7 numbers, but you can quickly see that 0.3 occurred more often. In the example here, we had 2 because 0.3 occurred twice and 4 occurred twice, and then none of the values in the next one occurred more than once. Mid-range is the last one. It's not used as often. In the case of mid-range, you're going to add the minimum and the maximum, and then you're going to divide by 2. Because you're using the minimum and the maximum values, if those happen to be extreme values, they will cause it to be off, and so it is not resistant. Some of the things that are nice about it, it is easy to use, it's easy to compute, adding 2 numbers and dividing by 2. It does give you another option, but sometimes it is confused with median, so you want to be careful. So here's our mid-range. We're using the same set of data as we had earlier. So we did the highest and the lowest. So the lowest number was the 14.1. The highest was the 55.6. Added them up, divide by 2, 34.85 megabytes per second. So things that you need to know when you're dealing with measures of center is when do I round and what do I round to. So if you have an answer that goes out more decimal places than the one that you have, you always go one more position. So if it's your original data is to the nearest 1 position or unit position, you'd go to the nearest 10th for your answer. If they're to the nearest 10th, then you go to the nearest 100th, and so on. For the mode, because you're not actually manipulating the data, you should not round at all. We're going to have times where we get to choose which ones we find, and we may not want to find all of them. We will want to know which ones to do and which ones not to do. If we're using the mean, we want to make sure there are no extreme values. If we're using extreme values, then it's a better choice to do the median. There are also times when you shouldn't even do the mean, median, mode, and mid-range. For instance, in this case, we have zip codes. They're numbers. We can always manipulate numbers, but if you found the mean of these zip codes, what information would it be telling you? Absolutely nothing. So we don't need to do it just because we can. Same thing with rankings. You can always manipulate them to find the mean, the median, the mode, and the mid-range, but they aren't really telling you any information. So if we have a frequency distribution and we're asked to find the mean, it's a little bit different because we don't actually have the data values to add up. So this is the formula that we would use. So we would, based on these symbols, we would add, once we multiply the frequency times the individual data value, we would add those up, Then we would divide by how many frequencies there are. So here's an example of that being done. Notice that the midpoint is being found. Remember, to find the midpoint, you take the lower end of the class, add the upper end of the class, and then divide by 2. So you're essentially finding the mean of each one of these classes. That's the midpoint. Then they took the frequency times the midpoint, add those all up. Then we take that 80/25 and divide it by the 50 numbers there are. And so we now know that the mean is 160.5 seconds. It only can be an approximation because we actually weren't using the individual data numbers, we were just using the midpoints. You can do the same if you want to know the weight of something. For instance, the grade in this class and many classes have a weighted system, so you could use that. The other one that is most commonly used, which we'll show in a second, is the GPA. Your GPA is weighted, and so each letter is worth a different amount. An A is a 4, a B is a 3, a C is a 2, a D is a 1, and an F isn't worth anything. So we're going to take our weights and we're going to multiply them by the letters. So 3 times 4, 4 times 4, 3 times 3, 3 times 2, and 1 times 0. Then we divide by how many credits we were carrying, and now we know we have a GPA of 3.07 in this case. Now, our numbers were actually whole numbers, and so we usually, according to our rounding rules, we should just go 1 decimal place afterward, but it is common practice in the college world or even in any world that you do GPAs to 2 decimal places. So we went ahead and did that here, even though the rounding rule said to go to 1. That was the end of measures of center, and next we'll be moving on to measures of variation.